A star, one of the most luminous in the Andromeda galaxy, just vanished. No explosion, no supernova. It was there, then it wasn't. And what it left behind is one of the most extraordinary things astronomers have ever caught on camera. You're listening to Stardrift FM. Tonight, a massive star quietly collapses into a black hole, no explosion required. China pulls off two historic firsts in a single launch, abort test and booster recovery. Europe's heaviest rocket flies for the first time with 4 boosters. Crew-12 docks at the space station on Valentine's Day. Vulcan has another booster problem, second time in 4 flights. The building blocks of life on asteroid Bennu formed in ice, not warm water, and a ring of fire is about to cross Antarctica. Grab your coffee. Let's get into it. So, when a massive star dies, it's supposed to go out with a bang. Supernova, one of the most violent events in the universe. The core collapses, a shockwave tears the star apart, and for a few weeks it outshines an entire galaxy. But what if it doesn't? A team led by Keck at Columbia University has been watching a star in the Andromeda galaxy called M31 2014 DS1. It was one of the most luminous stars in Andromeda, about 12 to 13 solar masses at birth, 100,000 times brighter than the sun. And over the last decade, it just faded away, dimmed by a factor of 10,000 in visible light. No explosion, no supernova remnant. It quietly collapsed into a black hole. They have 18 years of data. Hubble, NASA's NEOWISE, the Keck Observatory. This is the most complete observational record ever assembled of a star making this transition. In 2014, the star briefly brightened in infrared. That was about 1 solar mass of outer envelope being ejected as the rest fell inward. Then even that glow faded. Here's why this matters. Astronomers have noticed something called the missing supernova problem. We don't see as many supernovae as stellar models predict. The suspicion has been that some massive stars, maybe 10 to 30%, skip the fireworks entirely. They just collapse. This is the strongest direct evidence that this actually happens. A star that was there, now isn't, and a 5 solar mass black hole sits in its place. As Morgan McLeod at Harvard put it, we've known that black holes must come from stars. With events like this, we're getting to watch it happen. China just pulled off something no one has done before. 2 historic firsts in a single flight. February 11th, Wenchang launch site Hainan Island. The Long March 10 rocket ignites for the very first time. And on top of it, the Mengzhou crew capsule, China's next-generation spacecraft, is about to test whether it can save its crew during the most dangerous phase of flight. 45 seconds after liftoff, at maximum dynamic pressure, the abort command fires. The escape tower ignites. Mengzhou separates from the rocket. Parachutes deploy. Capsule splashes down in the South China Sea. Recovered within 90 minutes, everything nominal. But here's the part that's genuinely new. While the capsule was drifting down on parachutes, the rocket's first stage was doing something of its own. Grid fins deployed, 2 engine restarts, controlled descent, and it splashed down in a designated recovery zone. First in-flight abort test combined with booster recovery. Nobody's done that before. SpaceX's Dragon abort test in 2020 intentionally destroyed the Falcon 9. China saved both pieces. This clears the path for an orbital test flight later this year and a crewed lunar landing before 2030. The mission architecture: 2 Long March 10 launches. One carries the crew in Mengzhou. The other carries the Lanyue lunar lander. They meet in lunar orbit. The moon race is very much on. Europe just got its heavy lift capability back. February 12th, Kourou, French Guiana. The Ariane 64 lifts off for the first time. That's the 4 booster configuration. 4 P120C solid rocket boosters instead of the usual 2. And it doubles the capacity. 21,600 kilograms to low Earth orbit. Comparable to a Falcon 9. The payload, 32 satellites for Amazon's Project Kuiper constellation. Now rebranded as Amazon LEO. their answer to Starlink. Amazon has a brutal FCC deadline, half of 3,200 satellites in orbit by July. They've booked 18 Ariane 6 launches. Here's the context. When Ariane 5 retired in July 2023, Europe had 0 operational heavy launchers. For 12 months, ESA called it unacceptable. Ariane 6 flew in July 2024, but only the 2-booster version. Now the full range is online. Not reusable, not cheap compared to SpaceX. But that's not the point. This is about strategic autonomy. Europe launches its own military satellites, its own Galileo navigation constellation. You don't want to depend on anyone else for that. Europe is back in the heavy lift game. 10,000. That's how much dimmer that star in Andromeda got before it disappeared. 10,000 times fainter. Imagine the sun going from broad daylight to the light of a single candle, and then going dark. If you caught our last episode, we previewed this launch. Well, it happened, and it went beautifully. Crew-12. Jessica Meir commanding, Jack Hathaway piloting, ESA's Sofia Dinat, and Roscosmos's Andrei Fidjiev. 4 astronauts, 3 countries, 1 Dragon capsule. They launched February 13th at 5:15 a.m. Eastern from Cape Canaveral. 2 days later than planned, weather kept pushing it. And here's a fun detail. The booster landed at LZ-40, a brand new landing zone. First time SpaceX has launched and landed a booster at the same complex. But the big story is why this mission was so urgent. Remember Crew-11? They came home early in January. Medical emergency. First medical evacuation in the station's 25-year history. Since then, the ISS has been running on a skeleton crew, 3 people. For a whole month, Crew-12 restores the station to its full 7-person complement. Docked Valentine's Day, 3:15 p.m. Eastern. At the Harmony module, 200+ experiments over an 8-month stay. And Space.com's photo of the day? Vulcan 9 lifting off with the Artemis II SLS rocket visible in the background. 2 crewed spacecraft for very different destinations, side by side. Welcome aboard, Crew-12. Remember last episode when we talked about Falcon 9 having a bad week? Well, Vulcan is having a bad year, again. February 12th, ULA's Vulcan Centaur launches from Cape Canaveral. Mission USS F-87. Classified Space Force surveillance satellites heading to geosynchronous orbit. Less than 30 seconds into flight, one of 4 solid rocket boosters develops a visible problem. Nozzle burn-through. Fiery jet coming out where it shouldn't. The guidance system compensated, payload delivered to orbit after an 8-hour coast. Mission success. But here's the thing. This is the 2nd booster anomaly in just 4 Vulcan flights. October 2024, 2nd Vulcan flight, nozzle completely detached from one of the boosters. They investigated, found a manufacturing defect, said they'd fixed it. Space Force certified Vulcan for national security missions last March. Same type of booster. GM63XL, made by Northrop Grumman. Longest monolithic solid rocket motor ever produced. And for the 2nd time, the nozzle is the weak point. ULA had 16 to 18 Vulcan missions planned this year. This rocket is supposed to replace the Atlas V, which is being retired. A recurring booster problem is the last thing they need. Alright, this one rewrites the origin story of life's building blocks. Remember OSIRIS-REx, the spacecraft that grabbed a sample from asteroid Bennu and brought it home in 2023? 121 grams of pristine asteroid material, oldest stuff you can touch. New analysis just published in PNAS. They found 14 of the 20 standard amino acids in the sample, the building blocks of proteins, building blocks of life, plus all 5 nucleobases found in DNA and RNA. But here's where it gets really interesting. The standard model says amino acids form via something called Strecker synthesis. Warm liquid water, aldehydes reacting with ammonia and hydrogen cyanide. You need aqueous conditions. You need heat. The Bennu data says not necessarily. The isotopic signatures, specifically nitrogen-15 ratios, show these amino acids formed in frozen ice exposed to ultraviolet light and cosmic rays. Cold. No liquid water needed. Simple molecules, water, ammonia, methanol, frozen together. Radiation drives the chemistry. Lead author Alison Basinski at Penn State put it simply, our results flip the script. There are many conditions where these building blocks of life can form, not just when there's warm liquid water. If amino acids can form in cold ice plus radiation, that changes everything. Enceladus, Europa, comets, Kuiper Belt objects. The conditions for prebiotic chemistry aren't rare, they're everywhere. 3 days from now, the moon is going to pass in front of the sun, but it's not going to cover it completely. The moon is near apogee, farthest from Earth, so it appears slightly smaller than the sun's disk. That leaves a brilliant ring of light around the edges, a ring of fire. Annular solar eclipse. February 17th, the path of annularity crosses western Antarctica. 2,661 miles long, 383 miles wide. Maximum duration 2 minutes and 20 seconds. And here's the thing. Fewer than 20 people on the entire planet will see the full ring. The path crosses some of the most remote territory on Earth. Concordia Station, the French-Italian base deep in the Antarctic interior. Mirny Station, a Russian coastal outpost. That's about it. If you're in southern Argentina, Chile, South Africa, or Madagascar, you'll see a partial eclipse. Still worth looking up, with proper eye protection. And mark your calendars for August. Total solar eclipse. Spain, North Africa, Iceland. That one, millions of people will see. 2026 is going to be a great year for eclipses. So, the star vanishes into a black hole without a sound. China tests its moon rocket and escape system in one flight. Europe's 4-booster Ariane flies. Crew-12 docks on Valentine's Day, restoring the ISS to full strength. Vulcan has another booster hiccup. Bennu rewrites the recipe for life's building blocks, and a ring of fire is heading for Antarctica. This is Stardrift FM. Thanks for tuning in. We'll see you next time.